2. It's very groovy and it's 1975. So I'm not dressed weird at all. I just wanted to give you guys a lesson about sine, cosine functions and their transformations, okay? So I'm not here, but I'm kind of here, okay, guys? So let me adjust this a little bit, all right? Just know, because it's a 1975, I'll be using an old technology called the overhead projector, and you can access it through YouTube. So that means you can actually watch it over and over, however many times you like, but also you can stop it whenever you have a question, all right? So here we go, guys. All right, so you have this in front of you, a packet of notes that your sub has given you. So please follow along and fill in the blanks. So like I said, 13.7, what do sine and cosine graphs look like? How do you even graph them, all right? Here is our parent function that we're already familiar with. But you guys, we have more. Now we're going to be shifting it up or down, left and right. All right. Here we go, you guys. Y, here's your new equation. This is your STD form. A sine B x minus h plus k. Don't these values look very, very familiar? Yes, they do, right? You know that A is the amp, right? And you know B. B is what? Number of cycles. Yes, I heard you. All right? And you guys, think about it. X minus h, that occurred in so many different functions that we talked about. So h must tell you shifting from left to right, and k must tell you up and down. Likewise with cosine, y equals a, cos b, x minus h plus k. Something important I must point out is that, what was I going to say? Something important that I have to point out is, that the b is outside and the x minus h is actually inside together. That's very important that you write it that way. And as you can see inside on the bottom here, yes, amplitude is again absolute value of a. 2 pi over b is period, and that tells you period because it's 2 pi per period divided by b, the number of cycles. Phase shift, which dictates left or right, guys? So we're going to call it phase shift or horizontal shift. It's the same thing. And we have vertical shifts here, which goes up and down. But you guys, remember we talked about this? The midline changes actually to wherever it's shifted vertically. So we'll go through some of that, okay? So basically your graphs used to look like this, right? Your graphs used to look like this, right? But now they're going to shift, that's all. So they're going to shift, like maybe here, okay? Maybe it's going to start here. It just shifts, all right? So we'll discuss all that. All right, let's go on to the next page. Here we go. Part 1 and 2. Actually, part 1 and 2, I want you guys to do on your own without my help at all, actually. Let's go ahead and have you guys finish these. Well, maybe I'll go over the first one with you, okay? Describe the phase shift and the vertical shifts. So you guys, describe the phase shift and the vertical shifts. Easy. Because you know that the STD form is y equals a sine b x minus h plus k. Y equals a sine b x minus h plus k. But I know I meant to write here cos. Sorry about that. Cos, all right? So you guys, we have those two. And you guys think about it, okay? They just want to know the horizontal shift and vertical shift. So look here and here. So let's look at the first case. Oh, there's nothing. That means for the vertical shift, was there a vertical shift? You say no. No vertical shift, okay? But how about the horizontal shift or the phase shift, the book calls it, okay? And that means you look, oh, I'm sorry about that. The vertical shift, there was. Vertical shift, there is 1, right? It went up 1. Phase shift, there is no phase shift. Okay? So go ahead and finish that. Finish that really quickly. I'll give you some time. Stop the video. All right. Welcome back, you guys. Hopefully you check with one another But let's do this together. Vertical shift, phase shift. Vertical should have been down 2. Phase shift should have been left 1. Once again, it turned positive here since it's x minus h, the original STD form, all right? So you guys, next one, phase shift, vertical shift. Phase shift should have been left pi over 2, up 2. Check with your neighbors as well, okay? And phase shift here, vertical shift here, phase shift here, right 3. Since it's remained negative here, minus, okay? And it went up 2, since the k is now 2. That means the midline's gone up 2, 2, okay? All right, let's go to part 2. Stop the video and rewatch this if you have to, okay, guys? All right, let's go to part 2. Part 2 is here. And now this time, they're giving you the shift. They want you to write the equation. So let's try the first one together. So number 36, y equals sine x. So they want us to use sine x. Remember, I always like to remind myself of the actual equation. So here you go. Ya cosine b, x minus h plus k. So make sure you have that with you. And you guys, it says it moved pi units to the left. And that's it. No vertical shift. So easy peasy. Y is equal to sine x left. That means it went left. Negative, right? So it's going to be plus pi. Alright? So now stop the video and try writing the rest of them and check your answers back with me. So I'll see you soon. Stop the video. Alright, welcome back. So you guys, let's see. Let's check your answers here, okay? It says pi units down, pi over 2 units down. So cosine x minus pi over 2. Did you get that right? Give yourself a pat on the back or a smile. All right, next one. Y equals sine x, but it's 3 units up. So it's sine x by, plus 3. Awesome. Good job. Y equals, next one, 1.5 units to the right. To the right. That means cosine x plus 1.5. Did you get that? Just kidding. Of course, I hope not. Right means probably shifted to the right. So that means it remains minus there, okay? Next guy. Y equals cosine x, 3 units to the left and pi units up. So let's control the left and right first. So cos x plus 3 since it's left and plus pi since it went up. All right. Next, guys, y equals pi over 2 units to the right and 3.5 units up. So ready? Sine to the right. So it's minus x minus 2 pi over 2 and up 3.5. All right. You guys, if you didn't understand that, go back to your notes. And maybe after we do the lesson, you'll understand it better. But you know, the greatest thing about technology is you can always come back to it. Woo! Here we go. Part 3. Dun, 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 dun. So you guys, part 3 is all about graphing. You already know the basics of graphing, but now we're going to add some left, right, up, down shifts. So you guys, the first one I'm going to give you guys is this. So it has phase shift and vertical shifts. Uh-oh, don't fear. So you guys, y equals cos x plus 3. You know, for these kind of ones, I just like to do it this way. You already know that this guy, look at this, okay? Is there a vertical shift? No. Is there a phase shift? Yes. Left, 3. So you know your original graph, you guys? You know a cosine graph looks like this. Right, guys? Everyone knows this like superstars, okay? But you guys, it said it shifted 3. But you know, I like to do this as well. You see how this is one cycle of a cosine graph is 2 pi, and that means that half of it is pi. Well, isn't 3 a little bit under pi? So you know 3 is about right here somewhere, okay? So you guys, it shifted there. So what's going to happen? It literally gets shifted. So what's going to happen? It's going to become something like this. This guy gets shifted from here, right? So it gets like this, okay? So I have a more exact one right here for you. So you see this guy? He's actually depicting your y equals cos. It's shifted. Because the original guy was over here somewhere, right? Oh, the original guy was here. Okay? Oops, sorry, that's ugly. All right. So you kind of get the point? So these ones, it's okay if you just sketch for me, all right? And label your graphs, obviously. So for example, this guy is y equals cos x. The red is y equals cos x plus 3. Label that for me, okay, guys? All right, let's go do a real example. Dun, da, da, da. We're going to do number 35 first. Have you located number 35? All right, I'll wait for you. You found it? Awesome. Now, VIPPA is something that I created, but you can use any method. But I think it's helpful, at least for the first couple times you're trying to learn how to graph, okay? So you guys, first step of graphing, y equals 3 sine pi x minus 2. Whoa. Okay, so recognize all your A, B, H, K, all those important values, okay? So you guys, your A, amplitude is 3. So let's actually fill in VIPA. Amplitude is 3. Let's fill that in. What else do you know? Do you know the vertical shift? There is no vertical shift, right? Because there's nothing here. No K moved, okay? How about, let's go B. What's your B? B is pi over 2, because it's right here. But it says find the period. Well, period is simply 2 pi over 2. So your period must be 4. So let's write that, okay? Make sure you understand that, guys, okay? If you don't, just stop and ask your neighbor, because Ms. Chang is not there, right? All right, let's go to the next one. Let's go to the next step. All right. Oh, let's actually finish more. You guys, the interval we're going to save, so I'll put a star on that. But phase shift, you guys, look at it here. Oh, it's moved 2 to the right. 2 to the right. Okay, so we're ready to start. Woo! All right. You guys, step 2. Find your new starting point. And you guys, this is again Ms. Chang's method, but you can do it however you want. But you guys, isn't your starting point used to be 0? But now it's moved. How much? Hasn't it moved x minus h amount to your new period? Yeah, that's your starting of your cycle, end of your cycle. So you guys, it's 0. What's your x minus h? It's x minus 2 in our case. And our new period is 4. Make sure you understand that. And you guys, we solved the inequality basically. You add 2 to both sides, and you get 2 is less than or equal to, x is less than or equal to 6. This is your new end point of one cycle. This is your start point, beginning point. Okay, or start point. I'll put starting point. All right, guys, starting point. All right? All right. So you guys, let's go to step 3. Find your interval. You guys, we know interval. You know about your critical points, right? Remember, Z max, Z min, Z, wait, Z max, Z min, Z, right? Or max Z min, Z max, right? So you remember those 5 critical points. So interval, it's basically your period over 4. What's your period here? It's 4 in our case, it's 4. So our interval is 1. That means every part of your graph, it's actually moving by 1. Okay, they're 1 point away from one another. So you guys, let's do your 5 critical points. 1, 2, 3, 4, 5. You start with your starting. Do you remember your starting point was 2? That's your starting value, right? Your start point. And you also know your end point actually, which was 6. Remember? We had it from the other step. From this step. So you guys, next one is going to be growing by 1. In this case, it's easy, so it's just adding 1. Let's see, 3, 4, 5. And those are your 5 critical points. And your 5 critical points, let's start graphing, you guys. 1, 2, 3, 4, 5, 6, 7, 8. And guys, I'm going to just do some amplitudes here. What is our amplitude? It's 3. Was there a vertical shift? Let's go. You know what, let's back up a little bit. Let's just actually start with our interval. So you guys, 2, our new 5 critical values. So it's going to be 1, 2, 3, 4, 5. And you guys, isn't it 2? And it's a sine graph. So it starts at 0. And it goes up how many? 3. So let's draw some more. 1, 2, 3, right? To the max. It goes back to 0. It goes to the min right here. And then, whoa. And then it goes to 6, which is a 0. So you guys, isn't this our class 6 sine function, sine wave? Here we go. But you guys, didn't the midline change? Didn't the midline change, you guys? Was there a vertical shift? Was there a vertical shift? No. So y is still equal to 0. So it's 0 here. So in our case, it's okay for us to just write 1, 2, 3 because the amplitude is 3. So you guys, there you go. But you guys, you can't just draw one cycle like this. We need to see what happens later. So you guys, if you want to actually just continue it, you don't have to label everything, but just make sure that you note to me that it's continuing forever and ever. If you didn't understand that, please go back and watch it again. Okay, guys? Alright, but these are the steps. I'm going to do another 2 more of these graphs, okay? So I'll try that. So I'm going to change the page. Let's go to a cosine graph, okay, guys? So go ahead, no, let's just do 26. Let's go to 26 right here, another sine graph. Alright, so you guys, do your VIPA. Without looking, do your vertical shift, interval, period, phase shift, and amplitude. And don't forget, interval you have to save, okay, until later. So I'm gonna fill it in, but don't look. Try to check with me later, all right? So vertical shift. I'm not gonna talk anymore. Don't cheat. All right. Second step, go back to your notes if you have to in order for you to refer back to what you're supposed to do next. But I know it used to start at 0, and I know it shifted in our new period. So our new function is, and our period is 2 pi. When we do when we solve this inequality, we get negative pi over 4 less than or equal to x is less than or equal to 7 pi over 4. That's your new end point. This is your new start point. All right, guys? All right. Let's find our interval. So interval is period divided by 4. Your period is 2 pi, so you divide by 4, you got pi over 2. That means every critical value grows by pi over 2. So let's find our 5. 1, 2, 3, 4, 5. We already know our end point, 7 pi over 4. We know our starting point is negative pi over 4. All right, but we're going to have to fill in the rest. How? We grow by plus pi over 2. You keep on adding pi over 2. Pi over 2. So here's what I got. I got pi over 4. I add pi over 2, so I get 3 pi over 4. Next, I get 5 pi over 4. That means that's my critical values. I'm going to just sketch them here. But you guys, it has a negative, so I need to do a negative. And here are my negative pi over 4, pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4, and I know this is a sine. I know this is a sine graph, so I know that it has a 0 here. Max, but watch out! Isn't there a vertical shift of negative 1? That means this guy must be negative 1 here. But the amplitude is 2. So you guys, midline is y equals negative 1. Make sure I put that in a safe place here. And you guys, it's amplitude of 2. That means it went up 2. So if it goes up 2 from negative 1, that means it's going to be positive 1. Because it goes 0 here and 1 here. And then it went down, right? But it goes negative 1, negative 2, and negative 3. That's our minimum. So our max would be 1. Our min would be negative 3. Make sure you understand that. All right? So you guys, let's do this. I'm going to graph this. You guys, it goes z, and it's positive, so it's going to go wrong. Sorry about that. Right? It goes max, 0, min, and 0. So let's trace the nice sine function here. And remember, it goes on forever, okay? So sketch a little bit more to the left and right. Here you go. Good job. Give yourself a hand. That's hard work. All right. So you guys, if you understand a lot and you understand pretty well right now, then maybe you can actually stop the video and try graphing some. Okay? The homework is on Schoology for you. But if you want to watch another one, here you go. And I'll do this one really quietly. But for your sake, I've provided you with a cosine graph. And this is number 31. Like always, same thing, but a little different, right? Remember, cosine functions always start from the max. So you guys, fill in the VIPA. That means I'm going to do my vertical shift. Let's actually do my A and B first. Yeah, A is 1, B is 2. Period is 2 pi over B, so in our case is pi. So period is pi. Intervals later. Vertical shift, up, down 2. So I'm going to write down 2. Horizontal shift, yes, left, pi over 2. Amplitude, it's going to be just 1. All right, interval, we'll come back and fill that out, okay? Find a new starting point. Remember, it's 0, x minus h, and our new period, which is pi. All right, next one, I'm going to go 0. Ours is x plus pi over 2, less than or equal to pi. All right, make sure you're getting all that, guys. Stop and ask your neighbor if you have to, okay? And when I solve the inequality, I get negative pi over 2 is less than or equal to x is less than or equal to pi over 2. Here's our end point. Here's our start point. All right? Let's find our interval. How are our critical points growing, right? So you guys, interval is equal to period over 4. Our period is pi, and we divide by 4, so that's our interval. So you guys, you know, I've been forgetting to do this, but if you want to actually go ahead and fill in your interval here, pi divided by 4 is okay. All right? Not the most important thing, but it's good to write, okay? So you guys, intervals, you got your 5 critical points. 1, 2, 3, 4, 5. What did you say? Starting point you already know? All right, it's negative pi over 2, and end point is pi over 2. All right, but it's growing by pi over 4. So we know every time we have to add by pi over 4. Add pi over 4. Add pi over 4. Add pi over 4 to get from one another. So you guys here, did you guys get negative pi over 4? 0, pi over 4, and if you add, you get pi over 2. Make sure you could get those. And again, you go back here. Maybe I make this guy negative pi over 2, this guy negative pi over 4, 0. I don't want to put a dot there, just a 0 is fine. Pi over 4 and pi over 2. But remember, this is a cosine graph. So cosine graph means that you start at the max. But wait, let's actually take care of our amplitude at a new midline. You guys, our midline, wait, it started at negative 2. That means our midline is y equals negative 2. So that means this guy is actually negative 2 here. What's our amplitude? Our amplitude is 1. That means our max would be 1 above this, which is negative 1. Our min would be 1 below that, which is negative 3. So here you go, negative 1 here. Sorry about that. And negative 3 here. Sorry, let's write that actually on the actual graph. All right, you guys good? But here we start from our max, and then we go to our 0. We go to our min, 0, and max. So you guys try to drawing this graph nicely. It's going to go something like that, okay? And just make sure that it continues on forever. And this concludes our part 3 of graphing. Woo! All right, here you go, guys. All right, make sure you stop the video and take it as slow as you want, all right? Here we go. All right, next. Guys, part 4 is super hard. I hope you are ready, all right? So, guys, it's actually from your book. It's page 881, number 46, as it states on your notes. And you guys, you know, I think I told you this before, but did you know that sine graph is actually a transformation of a cosine graph? So we're going to prove that to you, all right? So you guys, think about it, okay? This sine graph here, isn't it directly related to this? Doesn't it look like it's been shifted from left to right? Yes, it does. So you guys, I mean, think about it. So we can actually write one in terms of another. So A says they want us to write a phase shift will translate the cosine graph, this cosine graph, onto this. So how much do I have to slide it over is what they're saying. And you guys, let's label these guys. Isn't this pi over 2? Isn't this pi over 4? Isn't this 3 pi over 4? We know that because this is pi here. That means this is half of that, and half of that, half of that, right? It may help if you actually label it. So I'll just finish labeling everything just for your sake. 3 pi over 2, and this is 7 pi over 4, and this is 2 pi. But you guys, I mean, if I slide this, how much? Oh, to the right. To the right pi over 2? Don't I actually get my sine graph? So you guys, part A says they want us to write in terms of this. So you guys, when does that happen? Oh, that's easy. When I slide my cosine graph to the right. How much? Pi over 2. So easy, you guys. Yep, I knew you got it. Try writing it. What do you think? Yep, you're right. Cosine x minus pi over 2. Now you try for sine now. So now they want us to actually slide the sine graph over. They want us to move the sine graph over so it looks like the cosine graph. So think about that for a while and look up when you're done. So you guys, make sure you press pause and let's see what you come up with, all right? So I'm going to write what. All right, what did you come up with? Yep, you would be right. Don't you just simply have to slide the sine graph over to the left, right? If you pull this to the left, how much? How much do you have to pull to the left? Same amount the cosine moved, right? So you guys, move to the left, pi over 2 for the sine graph, right? Then it'll be sitting on top of the cosine graph. So I'm going to circle this answer here. So I'll do the same thing. So cos x is equal to, when sine is shifted, how much? To the left though. So it's going to be pi over 2 to the left. Could you guys get that? Make sure you understand that, okay guys? It's pretty nifty, okay? All right. Hey, are you paying attention? I hope so, all right? Just because I'm not here, don't get lazy, okay? So you guys, now, this one's a super duper hard one. And you know what, you guys? I'll save this for next time. But try it for homework, okay? Try it for homework. All right, guys? Until next time, peace out. All right, guys? Make sure you watch the video over and over again as many times as you want to, all right? And I'll be back from Eco Geo with a nice tan, and we could have a nice lesson together next time I see you. Peace out. Bye. Okay, bye.